So we have just developed 5 special forms to be used in multiplying polynomials, but especially in factoring polynomials. We have 2 forms of perfect squares. We have a difference of squares, and then we have a sum and difference of cubes, right? So 5 special forms. How do we use these when we come to factor? We should be in a habit when we're factoring of being on the lookout for these special forms. When we're factoring a trinomial, 2 perfect square terms should jump out at us and tell us, hey, we should check whether that's a perfect square trinomial. But, if we don't catch that it's a perfect square trinomial and we go ahead and use the AC method, we'll get the factors right anyway. Spotting perfect square trinomials is actually going to be more important when it comes to something more complicated. When we're factoring a binomial, we're only going to be able to factor if we have one of our special forms. So difference of squares, difference of cubes, sum of cubes. There are higher degree ones of these, but we won't need any for the examples we see in this class. When we're factoring a binomial, we can only factor if it's of a special form. So when we come to a binomial that we want to factor, we have to examine it and say, is this one of our special forms? So here we have some binomials that we want to factor, and we're going to look at them and say, do I have a special form on my hands? So in this first example, we have subtraction. So I could be looking for a difference of squares or a difference of cubes. And looking at my terms, well, I see that x to the 4th is x squared squared. And of course, 1 is easy. 1 to any power is 1. So I can say that 1 squared is what I get from 1. And so this is a difference of squares with a is x squared, b is 1. And so x to the 4th minus 1, I can factor as x squared minus 1 times x squared plus 1. Now you might be looking at this and saying, hey, isn't that another difference of squares? And the answer is yes, it is. We could keep factoring from here. But for today, we're going to stop at this point. We're going to just do one round of factoring. Okay, next example. And here I have addition. So if this is going to be a special form, this is going to have to be a sum of cubes. 8 jumps out at me as a perfect cube. I'll have 8 is 2 cubed, and then y to the 6th is y to the 2 times 3. So 8y to the 6th is 2y squared cubed. 343, I probably don't know that off the top of my head, but I can get my calculator and make a table, and I find that that is 7 cubed. So this is in fact the sum of cubes. And the reason that I knew to look for 343 being a perfect cube is that my first term was a perfect cube. So this is a sum of cubes with a is 2y to the 3rd and b is 7. So 8x to the 6th plus 343 is going to factor as 2y squared plus 7 times 2y squared squared minus 2y squared times 7 plus 7 squared, or working things out in that second factor, 2y squared plus 7 times 4y to the fourth minus 14y squared plus 49. Okay, next. Let's see. I have subtraction. So this could be a difference of cubes or a difference of squares. But looking at this first term, 5x to the fourth, 5 is not a square or a cube. So this is not a difference of squares. It's not a difference of cubes. This is prime. Once I identify it as prime, I can stop. Okay, 25y squared plus 16. Well, 25y squared is 5y squared. 16 is 4 squared. But that means that I'm looking at a sum of squares. This is also prime. X cubed minus 25. Well, my first term is a perfect cube, but not a square. My second term is a perfect square, but not a cube. This is not a difference of squares. It's not a difference of cubes. It's prime. Last one. So something weird is happening in this last one. I have subtraction. So I could have a difference of squares and a difference of cubes. And looking at my terms, my x to the sixth, well, that's x to the third squared, but it's also x squared to the third. So that could be a perfect square or a perfect cube. My 64, well, that's 8 squared, but it's also 4 cubed. So that second term could also be a perfect square or a perfect cube. There are two ways I can factor this. As a difference of squares, I can say my x to the sixth minus 64 factors as x cubed minus 8 times x cubed plus 8. As a difference of cubes, I can say my x to the sixth minus 64 factors as x squared minus 4 times, let's see, x squared squared plus x squared times 4 plus 4 squared. So x squared minus 4 times x to the fourth plus 4x squared plus 16. Which one should I use? Well, it's going to turn out that we can continue factoring. And as we continue factoring, just like finding a prime factorization of numbers, we'll end up in the same place on either route. But notice that these factors are simpler, right? They're just two binomials. They're simpler to look at. They're simpler to work with than a binomial and a trinomial. If we have a binomial that we can see as both a difference of squares and a difference of cubes, we're going to factor it first as a difference of squares because it has that nicer form to the factors. For the moment, we're only doing one round of factoring. So if you see something that you can see as both a difference of squares and a difference of cubes, factor it as a difference of squares.